Let's review the midterm answers from EC 251 in 10 minutes or less. So the first question was, what's an embedded system? And that's a system that performs a specific dedicated operation where the computer is hidden or it's embedded inside the machine. Thanks, Whitney, for that answer. A microcontroller is a microcomputer that integrates a processor, RAM, ROM, and I/O ports all into a single chip, into a single package. Thanks, Brittany. Find two bugs in the thermostat control program. The way it's written, we would read the mode switch once and then never go back and check it again. So if the mode was off, you could never turn it on, or if you're in heat mode, it could never go to air mode. And if it was in air mode, you would never go back to heat mode. And also, while we read the current temperature in each loop, we don't read the desired temperature. So this program would never allow you to change the desired temperature. And the other answer I was looking for, but nobody seemed to pick up on, is this would exhibit a lot of dither. And that is, when you're right at the set point, it would turn on and off and on and off at an unlimited number of cycles per minute, which could be very detrimental to the equipment. So you'd normally have in here, once it's on, you'd leave it on for some amount of time. You'd slow down how quickly the state could change with a hysteresis or with a time delay. Number 3, a bit is a binary digit, a byte is 8 bits, a nibble is 4 bits, and a word is the largest collection of bits that the processor handles natively. For the 9S12, it's 16 bits, but other processors might be 8 bits or 32 bits, so it is processor dependent, a word. Binary is base 2, decimal is base 10, hexadecimal is base 16. Thanks, Garrett. Number 5. What's special about these numbers? Well, 255 is all ones in 8 bits. That's the largest binary representation unsigned. 256 is the number of different values that 8 bits can take on, so it's 2 to the 8th. 127 is the largest positive signed value. -1 is all ones. -128 has a signed bit set in all zeros, and so it's the smallest signed negative value. And similarly for 16 bits, 32767 is the largest positive signed value. 32768 is the smallest, it's a number of combinations, 2 to the 16th. 65535 is the largest unsigned. 65536 is 2 to the 16th. And -32768 has a signed bit set, so it's the smallest negative value. Thanks, Michael. The next one here, let's see. What do we do to initialize port T? It takes two operations. One to initialize the port, and then the second part of the question, to output all ones to the port, requires a write to 0240. And thank you, Jeremy, for that. Number 7, pseudo-ops are assembler directives. They're not executed by the microprocessor, they're just interpreted by the assembler. And these familiar pseudo-ops, org, FFFE, and FDB main, we put at the bottom of every program, and their purpose is to put the address of main, the entry point into the program, into the reset vector of the processor. So it's to establish the reset vector. It tells the processor where to go upon reset. It loads the address that's stored at FFFE and F into the program counter. Thanks, Stephen. The Z bit is set when an arithmetic operation results in a 0. Thanks, Jake. And we could subtract and branch of 0 by subtracting two numbers, and if their difference is 0, then they must be the same. Thanks again, Jake. RAM on the 9S12 DP512 is located at 0800 through 3FFF. Thanks, Kirsty. And addressing modes, inherent, is where the address is inherent in the instruction. There is no separate address like a clear accumulator. Immediate loads the accumulator with that value immediately, and so that would be stored as the next byte in memory right behind the opcode. direct and extended both require an address, either an 8-bit or 16-bit address, which are normally referred to as a hexadecimal number. Indexed uses one of the index registers like X, and we can use that to look up the 0th byte past wherever the X register is pointing at the time. And program counter relative loads the program branches some number of bytes plus or minus within an 8-bit range of the current program counter location. Thanks, Kai. Number 13, the addressing mode bugs in this program are highlighted. We need some dollar signs and some pound signs, and end, branch, end is a jump to here, which causes an infinite loop, which is a little unusual, but the programming error was that there's no pound sign there, and the familiar FFFE and FDB. Thanks, Sarah, for that. Number 14, what happens to the stack pointer and the program counter when you execute the return from subroutine is that the return address is pulled from the stack, and the stack pointer is incremented, and then that value is loaded into the program counter, and we jump to that location. The shift operation shown here, number 15, thanks Drew on the last one. On number 15, the shift operations, if we start with a negative number, the arithmetic shift left continues to double the negative number. So negative 1 becomes negative 2, 4, 8, 16, 32, 64, 128. And then finally we shift that bit out into nowhere land. Thanks, Paul. And the arithmetic shift right maintains the sign bit. So if we go from negative 20, shift it right, so the sign bit stays set. So you go from negative 20, negative 10, negative 5. Thanks, Alex. And the bonus question below is a subroutine. What does it do? So this subroutine does a brute force multiplication by adding B to itself a number of times. Thanks, Seamus. Good job, everybody, overall on the midterm. Look forward to lots of good assembly programming from the class. Thanks.